Hi guys, today we're going to be doing question 1 from 2.7 in your Maths Methods book from jacplus. So this one, James in a boat out at sea fishing, the weather makes a change for the worse and the water becomes very choppy. The depth of water above the seabed can be modelled by the function with this equation, so I might highlight that, where d is the depth of water and t is the time in hours since a change of weather begun. So look, before I do the questions, I always like to draw a quick little sketch of the function there, and you might like to do this on CAS. This would be a CAS question because all the extended response style questions are with CAS. So if we're looking at a sine graph, this one without the plus 12.5 would mean that we're going from negative 1.5 up to 1.5 and look like this, and then the period of this function is 2 pi divided by whatever's in front of the x, or the t in this case. So that's 2 pi times 12 over pi. And then we can cut out these, meaning 24. So that means one cycle of the graph is going to go to 24. So no doubt later it's asking us to draw it, but I always like to draw it first because then we can visualize what we're trying to find in the earlier parts. So now we have to consider that we're going up by 12.5 units. So we're going to be adding 12.5 to all the y values here. Oops, not 15.5, 12.5. So now I'm going to I'll put it over here. And negative 1.5 plus 12.5, that's going to take us to 11. So actually we are above the x-axis there. And then we have 0 plus 12.5, well that's going to be 12.5. And we'll haven't left much room there. And then 1.5 plus 12.5 is going to give us 14. And this would be our depth, and this would be our time. So let's get rid of that one, and I will draw the sine graph there. And we know that the period is 24, so it's going to go to here. So now I'm going to look at what the questions are actually asking me to do. So how far from the seabed was the boat when the change of weather began? So remember that this graph is showing the depth of water, so the height above the seabed. So the boat is starting here, so it's going to be 12.5. So A, it's 12.5 meters from the seabed. And then the period of the function, well, we've already found that to be 24. And that's quite a sensible answer there. 24 hours, so that means every day that the height of the water, or the depth of the water, I should say, goes through that cycle. Let's see what they want us to do next. See, what are the maximum and minimum heights of the boat above sea level? So maximum, well, from the graph, we can see the maximum height is 14 meters. And the minimum, from the graph again, we can see that that is going to be 11. So that's easy. And you see, because we've got the graph there, it's really, you really would be hard pressed to make a mistake. So I really do encourage you to draw the graph first. So we've already drawn one cycle of the graph, so I won't do that again. There it is. I might label these things a little bit better. So label the endpoints 24, 12.5, and then this would be 0, 12.5. And then, well, I could label my turning points as well, and that would be quite nice because then I can see at what times or how many hours after the change of the weather begun that I'm getting the maximum or minimum depths of the sea level. So halfway would be 12, that would be here. So that means that here would be 18, and here would be 6. So there we go, and you can see 0, 6, 12, 18, 24, so it divides nicely like that. So there's our one cycle of the graph. Let's move along. And we're on to part E. So I believe this one's a little bit more tricky. If the boat is h meters above the seabed for a continuous interval of 4 hours, calculate h. So let's think. I'm going to draw this graph again here so we can kind of analyze it a little bit better. So that was 11. We had 12.5. And we had 14. And it was a sine graph. And what it's saying is that we're above a certain amount. So the boat is h meters above the seabed for 4 hours. So it must be somewhere in and around the maximum there. So, well, if this maximum t value is 6, which we worked out previously, then if we want 4 hours for it to be above h, so h must be this value here. And actually I should probably do open circles because it says above, not at least. So we're saying this value here is going to give us the value of h. That's going to be the height of the water above the sea level. So we want to calculate what one of those are and sub it in. So if I go here to here, these give me x values. So the continuous period of 4 hours, we can find those x values because, well, this is 6, and on this side there's got to be 2, and on this side there's got to be 2. So 6 plus 2 is 8, and 6 minus 2 is 4. So it doesn't matter if you sub in a 4 or an 8, you're going to get the intersection of that blue line here and your sine graph there, and that's the value you're trying to find. So let's do that. We're saying that the x value, I'm going to choose 4, and our graph was 1.5, so d equals 1.5 sine pi times 4 over 12 plus 12.5. So that's going to be 1.5 sine pi on 3, so just cancel this down, plus 12.5. So, well, now, as we know, the most important part, like BODMAS, we do the most important first, so would be our sine there. So it's 1.5 times sine of pi on 3. There's pi on 3, here's sine, so it's root 3 on 2, plus 12.5. So let's neaten that up, and you'll notice I'm doing this by hand, so I'm going to get an exact value. It's not telling us to do it to any decimal, it is telling us to do it to decimal places. Look, I'll continue like this, but you could also just find this on CAS. So let's see, 1.5, which is 3 on 2, times root 3 on 2, plus, what's that, 25 on 2. So it's going to be 3 times root 3 is 3 root 3 on 4, plus 50 on 4. So I've just done a common denominator there. So I can say that h, let's move this down a bit, h is going to be 3 root 3 plus 50 on 4. And h, remember that we're measuring it in meters. So I can say meters. So that would be my exact solution there. To do it on CAS, which would be a lot simpler and more straightforward, would be that we could just sub our value in straight away. So you don't even need to use solve. We're just in main, and we're just actually typing in 1.5 times sine pi on 3 plus 12.5. And here's one I did earlier. That will equal 13.799038811. But we're doing to 1 decimal place, so we'll make it 13.8 meters. So that would be our final answer. So either by hand or on CAS, these extended response sort of questions are CAS questions, so you would be just fine to do it on your CAS. The understanding is the same. We're finding the intersection of the line here, trying to find what that line is that intersects with our sine graph when we have values of 4 or 8 for our time. All right, I think there's one more bit. Yes? All right, James is in a, I know we've already read that. James has heard on the radio that the cycle of the weather should have passed within 12 hours, and when the height above of water above seabed is at a minimum. After that, it'll be safe to return to shore. All right, if the weather change occurred at 9:30 a.m., when will he be able to return to shore? So I'm just going to draw that one more time. So we have 11, 12.5, and 14, sine graph. So it says that the weather is going to pass within 12 hours. We know that the period of this is 24. So that means that here is 12. So we're looking at when the water is going to be a minimum again. It's going to be a minimum here. So we already know that, well, from our previous graph, that, well, here's 6, 12, 18. So that's 18 hours. So we can say, well, here at 0, this 0 represents 9:30 a.m. So if 0 represents 9:30 a.m., 9:30 a.m. plus 18 hours is what we're looking for. So that's going to be 9:30 plus 12. It would be 9:30 p.m. plus 6 hours. And then that's going to be what? 3:30 a.m. the following day. So that would be our answer.